Hi, my name is Tom Bonner, Senior Director of Adversarial Machine Learning, and welcome to HiddenLayer's Black Hat Virtual Booth. Here at HiddenLayer, we're on a mission to safeguard machine learning models from threats and attacks. And as part of this quest, we're trying to inform organizations about the risks facing their AI and ML solutions today. In this demo, we're going to briefly introduce machine learning concepts and discuss some of the high-level attack techniques that are employed by adversaries today to subvert, bypass, and steal machine learning assets. Whether we realize it or not, AI is already all around us, in the apps we use on our personal devices, in our homes, cars, banks, factories, and hospitals. Nowadays, it's usually some form of AI that decides whether you get a mortgage or how much you will pay for your health insurance. AI is behind recommendations you see on social networks, media, and shopping platforms. It's even involved in unlocking your phone. The AI market attracts billions of dollars of investments each year, with over 75 billion invested in 2021 in private investments only. Likewise, AI-based solutions generate billions in revenue and are forecasted to grow rapidly. The technology that enables AI to learn and improve its predictions is called machine learning. At the core of any machine learning-based solution lies a decision-making system, which we call a machine learning model. Despite being a product of mathematical algorithms, machine learning models work much like a human brain. It analyzes the input, such as a picture, a sound file, or a spreadsheet with financial data, and makes a prediction based on the information it has learned in the past. Some models predict a class that the input data belongs to, e.g., which animal the picture represents. Other models can cluster similar inputs together. A price estimation system will use a model that outputs real value predictions, while an in-game AI will involve a model that essentially makes decisions. Rapid adoption across several sectors makes ML a very enticing target for cyber adversaries. We've seen this pattern before with various races to implement new technologies. Security lags behind. The rise of the internet led to the proliferation of malware. Email made every employee a potential target for phishing attacks. The cloud dangles customer data out in the open, and your smartphone bundles all your personal information in one device waiting to be compromised. ML is sadly not an exception and is already being abused today. The reasons for attacking ML are typically the same as any other kind of cyber attack, the most relevant being financial gain, getting a competitive advantage or hurting competitors, manipulating public opinion, and bypassing security solutions. In broad terms, an ML model can be attacked in three different ways. First, it can be fooled into making a wrong prediction, e.g. to bypass malware detection or security controls. Second, it can be altered, for example, to make it biased, inaccurate, or even malicious in nature. And thirdly, it can be replicated, in other words, stolen. Evasion attacks are already widely employed by cybercriminals to bypass various security solutions and have been used for quite a while. Consider ML-based spam filters designed to predict which emails are junk based on the occurrences of specific words in them. Spammers quickly found their way around these filters by adding words associated with legitimate messages to their junk emails. In this way, they were able to fool the model into making the wrong conclusion. Similar techniques are used to bypass malware detection engines and intrusion detection systems. Besides bypassing security solutions, evasion attacks can also be used to fool visual recognition systems. For example, a road sign with a specifically crafted sticker on it might be misidentified by the ML system on board a self-driving car. Such an attack could cause a car to fail to identify a stop sign and inadvertently speed up instead of slowing down. In a similar vein, attackers wanting to bypass a facial recognition system might design a special pair of sunglasses that will make the wearer invisible to the system. The possibilities are endless, and some can have potentially lethal consequences. While evasion attacks are about altering the input to make it undetectable, or indeed mistaken for something else, poisoning attacks are about altering the model itself. One way to do so is by training the model on inaccurate information. A great example here would be an online chatbot that is continuously trained on the user-provided portion of the conversation. A malicious user can interact with the bot in a certain way to introduce bias. Remember Tay, the infamous Microsoft Twitter bot, whose responses quickly became rude and racist. Although it was a result of mostly unintended trolling, it is a prime case study for a crude, crowdsourced poisoning attempt. ML systems that rely on online learning, such as recommendation systems, text autocomplete tools, and voice recognition solutions, to name but a few, are especially vulnerable to poisoning because the input they are trained on comes from untrusted sources. A model is only as good as its training data and associated labels, and predictions from a model trained on inaccurate data will always be biased or incorrect. Now, imagine spending vast amounts of time and money on developing a complex machine learning system that predicts market trends with surprising accuracy. Then imagine a competitor who emerges from nowhere and has an equally accurate system in a matter of days. It sounds suspicious, doesn't it? Machine learning models are just as susceptible to theft as any other technology. Even if the model is not bundled with an application or readily available for download, as is often the case, more savvy attackers can attempt to replicate it by spamming the ML system with a vast amount of specially crafted queries and recording the output, finally creating their own model based on these results. Such a copycat model can often perform just as well as the original, which means you may lose your competitive advantage in the market that costs considerable time, effort, and money to establish. When we talk about artificial intelligence in terms of security risks, we usually envisage some super smart AI posing a threat to society. The topic is very enticing as it has inspired countless dystopian stories. However, as things stand, we're not quite close yet to inventing a truly conscious AI. The recent claims that Google's Lambda bot has reached sentience are quite frankly absurd. Instead of focusing on sci-fi scenarios where AI turns against humans, we should pay much more attention to the genuine risk that we're facing today, the risk of humans attacking AI. Thank you for watching. We hope you enjoy the rest of the conference, and please stay tuned for future research and announcements at our website, HiddenLayer.com. Be sure to follow HiddenLayer on LinkedIn and Twitter, and to watch our second part of this series where we look more deeply into the defensive side of things. Thank you very much.